MITRE was the company that built the first air traffic control and collision system.
Cool.
We're the guys who built GPS. We're the ones who built, we had the first domain ever in the world, right? So MITRE.org is the first domain on the internet.
Hello, everyone. Welcome back for another episode of What's Spinnin here at 45 Drives. Today you're joined by me again, Brett Kelly, our host. My co-host today is joining me, our president and co-founder here at 45 Drives, Doug Milburn. And we are also joined by a wonderful guest today, and we're very, very thankful to have him on, Aaron Lippold. He's the principal cybersecurity engineer at the MITRE Corporation, and as well has been a leader in the open source community, supporting a bunch of different projects like Ansible, Puppet, Inspect, Docker, you name it. I've got to meet Aaron before. He's done a lot of cool stuff, and you're going to find out about it on our episode today. But without further ado, Aaron, thank you so much for joining us.
Hey, thanks for having me on. I really appreciate it.
Awesome. So yeah, you know what? Why don't we just we'll kick right into the meat, if you will. What we want to talk about everything that you do and what you do at the MITRE Corporation, how that benefits the world in general, organizations, people, everyone. But before we get into that, I always like to talk to people about their origin story of how they got into the industry, particularly in the tech world. There's so many different avenues in. It's fun to hear how someone kind of got in that path. So why don't you tell us about yourself, how you got into your career, and what was that initial spark that kind of took you down this train that brought you here?
Well, I mean, I originally was a normal computer science mathematics student at University of Illinois, and while I was a student there, I was able to work at National Center for Supercomputing Applications for many years. I was there as a student worker building clusters and high performance computers, big storage.
Nice.
I worked on a few of the clusters like Blue Waters and things like that, some of the original petabyte projects, right? And where we brought out InfiniBand and, that kind of stuff. And then I took a full-time job, worked in the infrastructure group there. And during that time, I got recruited by the Defense Department to help them with this newfangled thing called open source. And they wanted to figure out, how do we get the DoD using open source? And so I got recruited into the Defense Information Systems Agency, where I led up activities and projects related to open source technology like Forge.mil. I helped rewrite a lot of the DoD's policies on open source technology and utilization of that, rewrote contract language, FARs, DFARs, that kind of stuff. And while I was there, I also helped start up a few projects that some folks might remember, like Forge.mil, the DoD's first open source collaboration environment, where I got a couple of Fed 100 awards pretty young. I think it was even before I was 30. So that was pretty cool. And throughout that, basically I wanted to decide, right, because I came from the supercomputing centers. I'd given up Windows years ago. I'd sworn it off, 97. I said, that's it, I'm done. I joined the Linux user community and the SIG over there, Special Interest Group.
Nice. And
the LUG, the Linux Users Group. And I started with Slackware and all that kind of stuff. So when I walked into the DoD and they were like, here's your Windows box. And I'm like, ugh, how do I do a Linux box? And they said, well, we don't know how to harden it. So I started trying to figure out. They said, if you can figure out how to secure it, you can run it on the DoD network. So that's kind of what started a lot of the security automation work that I did, because I was efficient sysadmin.
Love it.
And so I started writing Kickstart files, and I started writing, shell scripts. And, after many, many years, they started to ask, well, how can we make this security stuff more quick? Because you're doing it in an hour. It takes our guys 3 months to do the same thing. And I said, well, we could, develop a language and develop standards. And so we started developing things like OVAL and SCAP and XCDDF and, stuff like that. The SCC tools and all that stuff that I gave to SPAWAR for them to flush out into real software. kind of developed into a framework of actions and activities. And over the years, I also started to integrate with other projects like open source projects. So Puppet, as a initial example,
Yeah.
I helped the original Puppet guys get their some venture capital from the intelligence community to start that company. And then that split off into Chef because they had an argument about which way they wanted to go. So they split into
Uh,
two companies, and
as
then
open source often goes.
yeah. And then Michael Dahan and I were working on Cobbler at the time to help do a redeployment of what became the DoD's PKI, PKE infrastructure, public key, types of things. And we used Cobbler to actually deploy that and automate it so that rather than taking 4.5 months to create a new PKE node, we did it in like 4 or 5 hours. And then that was what kind of led to Ansible, because Mike and I were like going, there's got to be a better way than shell scripts. We got to get off this shell stuff. So, Mike just said, okay, let's take what we learned and I'll write it into a language. And that's kind of how Ansible was born. So with that, I then migrated over to MITRE, where we started to talk about what in the defense and intelligence communities we called operational development and continuous development. And they weren't really terms yet. And so that kind of led to what you've seen now in the department and in a lot of industry where they're talking about continuous and ongoing deployment and, DevOps and DevSecOps. And those terms started to coalesce around 2009, 2010, and a lot of different people started working on them. And so when I came to MITRE in 2012, I started to unify a lot of that into what now became this security automation framework that we're running. And it's really a culmination of research over about 20 years into a project and a set of applications, utilities, and services that the open community can use to kind of forward this idea that we want to keep things dry. We want to share and share alike. We want to allow other people to streamline the expertise and the work and the successes that they've had into something that other people can use. And so that's kind of what I've been doing over the last few years. And it's starting to take off now. So I'm really excited to see so many participants and so many players, to include yourselves, which is great. Harkening back to my HPC days and big data. So
it's fascinating, Aaron. You mentioned there, you talked about the old days of a large storage cluster being a petabyte, and I think now we put 1.6 in a box now. Yeah. And my, how times changed. I always tell the kids here stories like that too. War stories, Brett, from the old days.
I'm even doing it.
Yeah, we used to put all this on tape.
Yeah. That's fascinating. Anyway, really cool, and I love that coming together of automation and security, which is the story here, really.
Yeah.
And how the two of those things come.
Well, Aaron said it best when he called himself an efficient engineer. Like, what's the old adage? Everyone loves a lazy engineer. They just get it done.
I say that so much here in the company. I say, everybody, I love lazy people who are driven to be
It's
productive. It's amazing.
And then efficient is the professional term for that. I love it. I love that.
Yeah.
But that's exactly the good underlining of security work is hard. It can be detailed, painstaking, and if you have to reinvent the wheel every time, no one wants to do it.
Exactly.
So, MITRE and your work and everything, giving that back to the people as that platform to jump from is enabling that, and it's great.
So let's dig in here. MITRE. Tell us a little about MITRE, a federally funded research and development center. Is that correct? Can you tell us a little bit about structure and the like, where MITRE is?
Yeah. So I'm also joined with another one of my MITRE employees, Lisa Fassold. She joined us as well. So, we can both talk to you about that. So technically speaking, MITRE is a research and development center funded by the federal government, right? So we're funded out of the budget directly. And we do that intentionally. We do it so that we're independent and so that we're not influenced by contractual requirements, so that we can be totally impartial. And then we can work on the actual um, core challenges that the government might have, where we want to not only make sure that both the contracting and what we call the performer side, right, the defense industrial base contractors, and like you guys, when you get a contract from a customer, right, are you doing the right thing for the public interest, or is the government telling you to do the right thing? And are they executing well? So trying to gain efficiencies, values, trying to gain, the proper kind of cooperation. So one great example is that if you look at defense industrial base contractor, they may be contractually unable to cross collaborate with teams that are working on similar work, but they're working for a different customer, but they can't talk about it with each other, right? Because the company itself, wants to make sure that they're respectful of each of their customers' privacy and all that kind of stuff. The FFRDC is purposely designed to cross collaborate. We call it reachback. And we're supposed to be talking with each other about what all the different agencies and services are doing, so that when we can gain those efficiencies, we have the knowledge, reach back, and the impact to be able to do that, to the benefit, right? Because we're getting paid by, your tax dollars. So we want to use those tax dollars efficiently. So that's what makes us kind of very effective a lot of times, where a standard kind of contracting mechanism probably wouldn't be as effective.
I love that, Aaron. But it's great. Clarity, security is in everybody's interest. Absolutely, everybody, especially the tax-paying public who pays for it all. And I love that clarity, security, and then, look, and of course, as you know, we're big on the open source thing. It's the essence of us, and sharing everything that makes sense to share is a wonderful way to do it. And I very much like the clarity in that. That's fascinating. It's a great explanation. So, so you're. Can you give us any comment on breadth? I guess a little more detail on who. Obviously we're a fan and work with you guys and you guys for guidance and tools and guidance. And tell us a little bit more about who else works with you.
So we work with every government agency in the U.S. government, as well as we have international partners, and partner with other governments as well. And we try to not limit ourselves, right? And we're working to, as you guys might imagine, right, increase our ability and collaboration with even the industry and commercial sectors as well.
Yeah.
Everything from startups to other companies and things like that. So we try to partner with everybody and anybody we can, because our stated mission is in the public interest, and that interest doesn't limit itself only to government services and agencies. Everybody is a player, and everybody has a stake in those interests, right? And so we try to go international. We just opened our offices in Australia, as an example, and we've got offices in Australia and Germany and Japan. And I think we have one in Korea, so all over the world. So we're global, and our partnerships reflect that.
I love that too, because when we first started to work together, I know you were communicating with a team member of mine on the sales side, Stephen McNeil. I remember Steve came down and was like, I made some friends at MITRE. You got to meet this guy. He's awesome. He wants to help us do this, this, and this. And I look at him a little bit. I was just like, wait, who's selling who here? I thought you were what? And then as I got to know what the organization was, and you got to work with Mike McPhee on our engineering team there, and then I went, oh wow, I was almost too built into the transaction nature of this industry sometimes, where once I realized what MITRE was here to do, and that concept of no, we want to teach everyone and we want to help everyone, so all rising tide rises all ships, right? And I remember the first call we had with you and another one, a coworker, and I was like, oh, these guys are awesome to work with. So Yeah.
Yeah. So to give you an idea, like the kind of stuff that MITRE's worked on over the years is MITRE was the company that built the first air traffic control and collision system.
Cool.
We're the guys who built GPS. We're the ones who built, we had the first domain ever in the world, right? So MITRE.org is the first domain on the internet.
Fascinating.
So, yep. Yeah. And so we've been able to touch everybody's everyday life, quite a bit. And our standards and specifications, right? Like the attack framework and CVE and CWE and the RMF and the 853. We were core and integral to all that kind of stuff. And we don't charge for it, right? We give it away. Um, you know, and we do that to raise those boats.
Yeah.
And like our original mission, like we started in 1958, working on what's called the SAGE program, semi-automatic ground environment. And it was a key defense system in the Cold War era, and it was used by both military and civilian agencies, right? And it wasn't something that we kept closed, right? We opened it up, and our mission, hasn't really changed, right? It's always in the public interest and always building those technologies that are needed by everyone. It just evolves as technology evolves and time evolves.
Yeah.
Cool. And one last question about you, Aaron. Your role, you got that principal architect title. You tell us a little bit more about when you go to work and what you do, and where's your fun? Like, what's the fun stuff you do in particular?
So, well, thankfully now I am old enough or successful enough, right, that I have a team. So a lot of the hard coding work that I might do, right, I get to delegate that. Thank God. So I don't do as much hacking as I used to, right? So, I hand it off as a learning experience to my younger people to write shell. But some of the fun things that I get to do is I get to talk to a lot of government leadership and try to help them figure out working strategies. Like you guys might have heard of this new Swift thing that's coming out and this new risk management framework that they want to try to do to gain more efficiencies. I get to go talk about that and go, okay, what actually makes sense? What can we really get done? I love the marketing of the idea, right? But how do we take marketing and how do we make it reality, right? So I get to go figure out those types of things and horse trade back and forth to figure out what we could actually do. I also get to play around with things like what does the reality in the current state of artificial intelligence look like relative to paired programming, and how can we gain efficiencies there? But also, how do we figure out what does it mean to secure and validate that those new technologies are actually secure? So we will probably have to go write some security guidance about what are the top 25 things you want to scan for your AI to make sure it's secure. We're talking about those kinds of things. So it can be quite a few things that I get to do. I also get to figure out, well, how can I go increase? Because I've been asked, right, by a lot of different sides to figure out, well, you've done a lot of good value here. How do you make this more accessible? How do you make it more usable by people in industry? How do we make sure that people know, right? Like you guys had this problem. How do we go STIG something? How do we deliver it to our customers?
Yeah.
Right. And, sure, it's been there for a while. We haven't been the best marketers. How do we do better at that? Right. So, how do we set up a conference so that every year all these players like yourselves, right, are going to be able to come together and actually talk about this stuff so that you guys know everybody is there? And how do we increase collaboration?
Nice.
So
that's fascinating. You talk about that. I think of description of my career. A lot to do with it. I was a pretty hardcore technical guy in very different areas than you were. But my love is that whole thing of what can be done and how it fits together with what's useful. Our constraint in private industry is, of course, is it useful enough
Yep.
that people
Right.
wish to buy it is the constraint we have, which is pretty constraining, but you have a similar, is it useful in general is, that's pretty cool.
Yeah.
So I can very much relate to that. Brett, why don't you, let's dig into security a little bit.
Let's do that. And before we jump on, I want to compliment you and your team, as you were saying all the fun stuff. You go into the security world, and this is my biased perspective, and maybe I was right, maybe I was right, but I always looked at security as boring and monotone, and you follow the rules, and you're not allowed to have fun. But when we're doing STIG, we're talking to the MITRE guys, and I was like, okay, here we go. And then we get on, and I met you and another one of your coworkers, and I was like, this is fun. And where you started with the philosophy of, we're not following the rules to follow the rules. We're following the rules to capture the essence of what we're trying to do here. And that's everything that I wish people were. Anyway, so I wanted to compliment you there on that. And that's the type of stuff I think that will get people way more comfortable with approaching security and not trying to be like, I don't want to deal with this, because it's not always the most fun thing in the world, but it's necessary. And it starts with that philosophy of knowing I'm not just checking a box. I'm trying to capture the essence of why we're doing it. So I think you guys are doing a pretty good job at that, in my opinion.
Yeah, and the one thing that I think you guys kind of keyed into when we were talking about it, right, was that the security stuff that we're doing, really, there's nothing magical about security. Security is good engineering.
Yep.
The security control or the requirement that I've written down is nothing more than somebody got owned by not doing a good thing a year ago, and I wrote it down on a list and I gave it a name, right? But it really is just a specialized kind of functional and unit testing and quality, in quality control, QA, right? That I just happened to label with something called hey, you should have complicated passwords, right? We figured that out, right? Password 1 is not the thing we want to do. All right, so let's agree on what we're going to call that. But that's just solid engineering, right? So our developers, right, for years have been under the impression that this security stuff is something somebody else needs to worry about.
Yes.
No, they're the ones that write the software. They're the ones that have to engineer it well. And I'm really trying to just show people how to get the credit for the good work that they do, and also do all this other security stuff, which is really things that they want to do anyway. They talk about it in a different way, right?
Yeah.
And I'm just trying to give them that nomenclature and that verbiage.
It's cool. I make the analogy to quality. The manufacturing side, and their service side too. Yeah. And it is, people think quality is inspecting or something. Quality is making great processes.
That comes and
it's engineering your processes beautifully. And so,
what is DevSecOps, right?
Yep.
It's Henry Heinz and Henry Ford's industrial practices applied to software, isn't it?
Exactly. Yeah. Right on.
But it's great because DevOps too, because even people, they don't understand it yet. I didn't understand it first, but it's not a new language. It's not it's a mindset. It's a philosophy. You can't just be like, oh, we're going to start doing DevOps. Are you going to ready to change your mindset and how you operate and that concept?
Yeah.
So, cool. So let's dive into some of the other things. So the first thing that comes up when at least when we started talking to MITRE and everything, we wanted the word STIG. And for those listening who might watch Top Gear or anything, it's not the driver who does all their stunts for them. It is more of a guideline, I believe. Anyway, but we've got the expert on here. So why don't you tell us, what is a STIG? What does it do?
So a STIG is a Security Technical Implementation Guide. So it's literally the most engineering named thing you'd ever, right? Because it comes from SRGs, which are Security Requirements Guides. And they are a list of requirements of security best practices. Like, you should manage your passwords. And when you fire somebody, you should have a process for changing things and, fashioning keys and doing all that kind of stuff. Well, whenever you take those general requirements and you apply them to a specific kind of system, so let's say your, Storinator, right? Running Ubuntu or Rocky or whatever it is, right? How you implement those requirements changes versus if you were to go put it on one of your Windows-based systems, right? But the spirit of what you're doing is the same. So the technical implementation guide is how you implement it on that platform, on that version of the architecture. And they're not different requirements, they're just different recipes for it. And the STIG is a recipe for those security guides as they come through. And that's really all it is, right? And we talk about these things. People understand what a STIG is because they also know what a CIS benchmark is. Same thing, right? A vendor best practices guide, an admin guide, a security admin guide, right? That vendors have been putting out for years. That's your variant of this same document. And that's all a STIG is just how do I implement these best practices and requirements for this thing on this kind of box or this service or this system.
Awesome.
That's all.
That makes sense. And I'll jump backwards now that you said it, the SRG. It's more of the, like you said, it's here are the rules as we've thought them up. The STIG is more of the here's how you can effectively implement them on your various operating systems. But going back to the SRGs, does MITRE, who writes those SRGs? Where does that come from?
So MITRE has had a hand in it for quite a while, but really the company or the organization, right, in your terminology, that is responsible for it is an organization called DISA, and that's the organization I started in government in, the Defense Information Systems Agency, specifically their Field Security Office, which I think they now kind of call their Enterprise Security Office, but it was the FSO when I was there. And they're the ones that write the general requirements. So they say for any web server, for any NAS, for any switch or firewall, right? Here are the 100 things you should do. I'm not going to tell you how to do it because there's 50 different NASs out there, and you do each of these 100 things in 50 different ways.
Yep.
But we're going to tell you what we think a NAS should do, or a web server, or a database, or how you should appropriately harden and secure it. And they're the ones that are responsible for that. The vendors themselves, you guys, are actually responsible for writing your STIGs because it's your software, it's your platform, it's your hardware. I gave you the 50 rules. You tell me how you'd configure it.
Yep.
I mean, I could reverse engineer it, but it would take me 5 times as long as you that wrote the code. So that's where we invented or created what we call the vendor STIG process. And that's one of the things the SAF actually provides is an actual web application to help you go through that process. Because the DoD in its infinite wisdom decided the best way to manage that process was an Excel spreadsheet, which isn't the most efficient.
Yep.
But
It's all right to prototype, but yeah. And so
that's one of the tools we open sourced, right?
And is that Vulkan, if I'm correct? Or is it?
It is.
Yeah,
that is Vulkan.
Yeah.
And that was actually built between us and VMware. It was actually VMware themselves that paid us. So we did a pilot for the DISA CTO's office. We then published that code to the open source. The VMware guys that were the largest producers of STIGs in the world next to the DoD, because they had like 60 STIGs they had to manage, they'd gone through this pain for many, many years. It was actually such a slow process that by the time they'd get one STIG done, they'd be publishing the next major version of the product. So they'd get version 7 of the STIG done, and they're already GA on version 8, which just wasn't the speed they needed to push this guidance with.
Yeah.
So we built Vulkan and then open sourced that. And now they're using it to manage all their STIG documents. And, I think you guys have started using it as well. So.
We have.
And then in connection with that, we have a whole next set of tools like our visualization tools and Heimdall and, our work on the Inspect project to help make security guidance, scanning, and validation easier. And where we don't have to repeat ourselves, we don't. So I'm not going to write another configuration management language. I helped create Puppet Chef and Ansible. That's good enough. You guys got enough configuration management languages there.
Yeah.
So,
Awesome.
So I just reuse those.
Perfect.
And that's really why it's a framework, right? Not a tool, right? People ask me all the time, how do you download the SAF? Just like, how do I install DevOps, right?
Yeah, exactly.
Right?
Yeah. I love that. And then, so I want to ask this question then, because you kind of answered it, but like, who's responsible for the STIGs? Well, the vendors are. We have to implement the rules, but like, what is MITRE's role in the STIGs? Because you guys are giving a platform away on that, Are you not? Because I know that we've used some of your work from your public GitHub.
Yeah, so what we do is we help other teams implement an easier way to create automated testing for meeting the STIGs, be it automated configuration management, right, or hardening, as we call it, and then automated validation evidence.
Hmm.
So what we've tried to do is, you know, we didn't write all the STIGs. We helped maybe do peer review on them and stuff like that,
Gotcha.
and say, oh yeah, you might want to think about this and that. But ultimately, that was a document that the vendors published with DISA through their process, and then somebody said, well, how do I apply it? And then how do I prove that I applied it? And how do I do that efficiently? Because the STIGs are written such that you as an operator would be able to sit down in any data center you want and sit at the terminal, type commands, look at the output, and go, yep, that's hardened. That's correct. Okay, great. Next. Right. That's not very efficient, right? So we're trying to figure out how do we take what could take 2 months and make it 2 minutes, because we have to do it at scale for 100,000 boxes, right? How many NASs do you guys have out in government data centers, right? A million, 10 million, whatever, right? 100 million, right? So can you imagine if you had to go run the STIGs every 3 days to validate that you're still secure, and you had to do that by hand?
Yep.
There's just no way to do
You'd
that,
have a
right?
never-ending backlog.
Yep. Not possible.
Yeah.
Like you said earlier, it is the curse of like bureaucracy, and rule checking is good. Checklists are good. It makes sure the quality's there and everything. But this world moves so fast. There are people changing things so much that you can't just do the brute force way of going slow on it. So, it's very interesting, because one thing that I've seen too is on another side, where that seems to be coming up a lot, is FIPS validation. Like, there's such a long list of people waiting to validated on, I think, 140. I'm going to forget the number. But then, the next one's coming out soon. So, anyway, it's interesting that way. But, okay, so this is where I do want to go. We have a lot of government customers. We've talked a lot about how this came from that sector. Does this only apply to governments? Should private industry who's not working for the government really care about implementing a STIG for their product or anything like that?
Well, they do in a way. The commercial industry started with the Center for Internet Security, which was actually started by some guys who retired from NSA many years ago. And they said, hey, the industry doesn't have an organized set of documents and things like that. So the CIS is one start of that, right? Where you have the CIS benchmarks and the multiple levels, right? Level 1, level 2. But that's evolving such that like CIS level 3 benchmarks are basically functionally equivalent to the amount of checks and the fidelity that a STIG is.
Yeah.
And it also doesn't cost you any money. You don't have to pay anybody to do the STIGs, because we publish the STIGs as a public domain document. So in most respects, right, corporations and companies, you either decide to ABC, right, adopt, buy, create. Most companies, right, for many years have created, right? They have their organizational security requirements. They've got their list. They also then have the same problems that anybody else does in any kind of data center. How do I only buy, because sysads, they're expensive if they're any good, right? So I can't go hire a lot of them, right? And so they get into that same cycle. So then they say, well, maybe instead of creating, now I'm going to go back to, buying, right? And so, all right, maybe CIS, but CIS gets expensive. So, now a lot of people are starting to really look at adopting, right? Which is kind of why we put this out into the open source community. So corporations could take the 90% of the STIGs, right? Because the STIGs are really just an organized sets of pain and lessons learned, because it was the US government that really started this whole, how do you manage a good data center? How do you do so securely? How do you make sure it's stable? And how do you make sure it's resilient? Because, things like, hey, missile systems and yada, yada, like some pretty important stuff. And they had to figure it out quick and early. There's no reason that companies shouldn't borrow from that. And if you want to use 75% of the good, well, that's fine if that's good enough for what you need to do.
Yeah, it's better than nothing.
Yeah, it's why figure it out yourself?
Exactly.
take our pain, take our suffering, take our mistakes, and use them to your benefit.
We call that the DIY iceberg.
Yeah.
That's one of Doug's terms where, it looks like it's only that much work. Well, the rest of it's all under the ocean.
We use the word just when we create, right?
Yeah.
We'll just do that.
That should take a week.
Yeah. Whatever my developers tell me, I double it. Most of the time.
Yep.
Oh, that's funny.
Yeah, so it's not a requirement, but it would be a smart strategy.
Yeah,
I think personally. Or if your organization, right, the most important thing is your organization decides on a standard and decides on a business process and a pattern and follows it and figures out a way to make it consistent, right? Because even if you're 90% right and you're 90% right consistently, that means you can functionally and with some efficiency resolve the other 10%, right? But if all your data centers and everything that you're doing all over the place is everybody's free reign, who's ever the grand Pumbaa admin, right, at that data center does whatever they want to do, and then somebody else does it a completely different way, that means that you're just buying that problem every single time, right? Rather than, working together. So the most important thing is that any company develops a process and a procedure. And then if you want to borrow processes and procedures from those who want to share their experience, that's a pretty easy sell, I think.
No, I love it. I think our whole role in this industry, other than engineering, the hardware we make, but our implementation is open source, really see ourselves as a standardizer, an open source, and having you guys with this framework to take that experience and getting away from craft.
Yep.
Right. Getting structure and how people do the work, getting away from the craftsman, the results reflecting who did it, and trying to get consistency out of there. We do it in open source implementation, storage, and virtualization, and adopting this into our security is just, it's just comforting, very, very comforting. That, as I said, the potholes that other people drove into and broke wheels on, that we have that map and just and how to cover that and avoid them.
Well, one of the things I've always liked about your guys' company is that you use straight up commodity hardware, right? And that you're using literally an open platform, right? So you're following that open hardware model, right? You're not trying to paint your customers into a corner, which I personally, right? And this comes back from my NCSA days, right? Penguin Computing. You guys remember Penguin? Right. And those guys from the HPC world, right, they did the same thing, right? Where it's like, unlike other vendors who decided we want to force you to use our software, our methods, and even heck, our hard drives, because we're going to hard lock it in firmware or some craziness like that. I've always liked that approach. So you guys adopting something in the open, right, for all of your processes, it just goes right along with, kind of the history of your company, in my opinion.
No, that's exactly it. Everything we do, I don't like being locked into proprietary. I do not mind paying for value, paying for work done. We love it. Nothing better than a good vendor.
Exactly.
But, the gamesmanship and contracts and fine print, we're not fans of. So everything is open. You want to deal with us, come on in, choose what you want from us. We'll do the whole thing for you. But we need to do it better than the other guys are going to do it for you. And otherwise, you're free to choose. That's the marketplace. We love it. We embrace it. Open source is so cool being able to take it.
Especially with supply chain nowadays too, you guys need that flexibility just as much as your customers, right? Because,
absolutely.
Yeah.
And
things can just go away unexpectedly.
Well, we saw that in COVID, right? And the supply line shortages that you would see, like in particular, like not quite the storage world, but the switch vendors. Well, that anyway. But we got to get a lot of wins over other people by being able to, your lead times are still, you didn't change your lead times? And because we were flexible that way and we had such a wide chain of vendors. And
it was wonderful. I don't think we had any major delay in anything we did. We kept our lead times right through. But there was a lot of dancing going on in behind the scenes to do that.
And that's at the products going, and he nailed it. Aaron nailed it when he said the flexibility of what it was, because people aren't necessarily buying this particular motherboard or this particular drive. They're buying the form, fit, and function of the product. And as long as you're maintaining that the whole time and consistency, you can't just switching vendors can piss people off, because then all of a sudden their management interface API uses slightly different calls, and then that sucks and everything like that. So there's some consistency you want to do there, but that balancing point. I know you almost don't think about it in the hardware world as much.
But we do the same thing. You talk about building a framework, building tools.
Exactly.
We operate in a system called Princess, been built in-house. It's got I don't know how many million lines of code, quite a huge database right now, and everything runs in that. So our ability to manage open source, both the software side of it, but also very much the hardware source, that opening of hardware. And how do we go? And how do we put a serial number? It's enterprise we play in. That's our primary market. Yep. And how do you do it? So if we sell something to somebody, we know exactly the minute they call, we know exactly what's
where
there.
it came from.
And how do we put stuff in that doesn't cause problems? We don't step in the same potholes. We do exactly the same approach. Standardization, build systems, standardize, build systems. That's what's allowed us to do that.
Yeah.
So the one question I have is, I know that we've been working, back and forth. So what brought you guys to decide to kind of adopt, kind of what we were doing, and, how is your experience as an end user, right? This is your chance to complain and force me to agree to things on air. Yeah. So,
Yeah. Well, let me start
Go
very,
ahead.
very general, because my hands aren't in this project. But you know what? Security, the government world, big part of what we do. I don't know if is it majority of our business? I don't know. It's pretty big. By the time you go, federal government,
It's been growing.
municipal, state, and then derivatives out of that. It's got to be the majority of what we do. Very security concern, and lots of customers of ours have had problems.
Yep.
So anyway, that whole thing of just getting better at it, we've wanted to climb that hill, and we want to become excellent at it. And we weren't bad in any which way, but
We weren't bad. We weren't. We hadn't addressed. The way I always saw 45 Drives is we were building. We were just selling hardware. We were built. Actually, the beginning of 45 Drives, we were selling unassembled chassis to people in the way of do you want to buy a storage server not through the enterprise legacy
15
models?
years ago or whatever. Yeah.
Here's your bill of
2010,
materials.
yeah.
Here's where you can go get all the parts. You buy the metal from us.
Yeah.
People are like, we love it, but you got to build it for us, because my boss isn't going to let me do this. And then so the way we just kept, as we would do something and hear back what someone wanted more next, you know what I meant. We'd be like, all right, let's start doing that too. And we had that wonderful understanding in the early years of like, I don't think we're allowed to say no to anything, but it was wonderful for us because we kept just going, oh, now they want service? Great, let's build a service team. Oh, we need our own UI. Great, let's build off the cockpit background and build Houston.
With the framework of always building process. Building process. So we get to security, and it's just a no-brainer what you guys are doing. It's just exactly where open source, we contribute to it, we use it, and that whole thing of helping for our customers, it's got to be 100% solution in government. Like, it's got to work. It can't have holes in it.
Yep.
Most of what we sell now is full systems, full support, and it's just got to work. So upping our security game, how do we do that? It's going to be the open source world. Mm-hmm. You guys are bang on. Let's get to the details. Brett, why don't you take that over in the details of work with these guys? And I've heard nothing but, glowing. It's just such a good match. I think that, so what do you say about the execution of it?
The execution of it's been great so far. And so what's been going on is, when we got in contact, and like we were saying about the business, and more and more people were asking for STIG support and everything like that. And so when we started working with you guys, the first call that I joined, because you had been working with a coworker of mine for a little bit as he was learning the process, because that's what we've talked about this whole podcast. It's not like you can just buy a STIG image or something like that. It's the adoption of the mindset. So I will put my hand up and admit it, that I didn't understand what it was at first. And I'm hearing Mike telling me what he's doing and everything like that. And then he came in one day, he goes, I finally got on the phone with Aaron and his coworker, a coworker of Aaron's. I think I get it now. We were doing it all wrong. This is what it is. And I was like, okay, all right. I see it now. And then so we joined a call. And what the big thing for me was when that first first call we had where I joined you, and that understanding that you shared was, this is all about understanding the spirit of what we're trying to do. We're not just doing it because we have to do it. And I don't know, it resonated with me big time. So to speak details of how it's going a little bit is, I'll admit on our end, it was a lot of learning of what we have to do, how you should think about it, and everything like that, and learning to use the tools like Vulkan and everything. Because at first, and you're like, all right, let's pull the Excel sheet out. We'll do it this way, and then you're like, nah, it's not scalable, right? So, I mean, as we go further in this too, because we got to so far where we're at with this project, right? Our end goal is to have all our storage solutions, various storage solutions, STIG certified, ready to go. We're going down the rocky path, which is the downstream of REL, because we are contributing sponsors of the Rocky project. Actually, proudly will say we were one of the first founding
sponsors.
We were founding besides CIQ, which is
CIQ and us,
which is Rocky.
Yep.
But no, they're not actually. They're very separate things. Rocky, or the RESF. Anyway, where I'm going with all this is Rocky, and we're doing it in layers, right? So the operating system ready to go. Our Houston storage solution, which means you can have all your NAS. The NAS is Houston plus Rocky. That is what it is. Then from Ceph, we want to work with Proxmox and like you said earlier, we don't want to go change Proxmox. We want to use our partnership with them to get there with that. So, so far it's been going great. We're just nearing the end of getting Houston ready. And what I like about you guys is it felt, and I'll end on this, it felt a lot like, when you get taught to learn a bike or ride a bike, and you guys had your guiding hand on the back of us as we're going and going and going. And at one point we look back, Mike's driving the bike with Aaron's waving back there.
Yeah, I love it.
And we're, and so as we got through that first little bit, you didn't do it for us. You taught us how to think through it until we were driving down the road, realizing that you let go a while ago. So, and we still check in and everything. So, you know what? You did say, is there anything that could be better? And I genuinely mean this. No, I don't think so, because that concept of teaching a philosophy and teaching how to think is way more important than just telling us what to do.
Well, that's great to hear, and I'm glad. I'm glad that you guys really took the teach a man to fish, and really ran with it, and you were most importantly open, to it, right? Because you didn't take it as a defensive kind of, well, I've been doing it this way for years, and But I guess my real question is, now that you understand how to think about this, in a more flexible way, I would assume, right, that. I would assume that 90% of what you've learned and what you can bring, you're just going to bring to the base of your platform anyway.
Absolutely.
And, right? So it's like everybody, not just the government customers that use your products, right? But every single end user of 45 Drives is going to have a fundamentally more secure, and better product.
Wonderful.
Right? And they're not even going to look at it, right? They're not even going to know what a STIG is, right? But they're also going to know that they get much fewer DDoS attacks or, whatever, ransomware. And, hey, it just seems to work. So,
thank you.
At the end of the day, that's really the passion of putting this out. And this was the same thing when we pushed out SE Linux as an example, right? So it was the NSA's open source creator program that pushed the SE Linux and SE Android project for the same fundamental reason of just general better security for all. So,
awesome. I want to thank you too, because I did ramble a little bit there, but I love the way you said that, because I missed that point, and that is the kind of marketable point on what we want to say too is this is for everyone. I think we said it at the beginning of the podcast. The rising tide raises all boats. It's just like security isn't, and we said it again with the quality team. Security isn't the internal cops that just come and tell you if you did something wrong or not. It's a mindset that everyone should build in, right? So that's exactly correct. As we go through this work, all our stuff hardens up. It's part of one of our key perils that we want to. We've got an initiative that we're doing on our side of education, both videos, blogs, and everything, of how to build and understand your storage system and backing it
Best
up.
practice storage architecture.
Exactly.
Which is based on functionality, but also perils.
Exactly.
And security, cybersecurity, we have our Snap Shield thing that's this additional layer. But there's the whole, if you don't have good security architecture, your data security, your data storage is not secure.
Exactly.
So it's part of the whole game, and this is upping our game in that, which we teach out.
Yeah, and the understanding of that is when we say perils, what we mean by perils is like what's all the things that are going to destroy your data? Hardware failing, bit flips, people deleting stuff by accident, people coming in and ransomwaring you.
System accidental, intentional deletion, ransomware. And then we have a final one we call meteor strike, which is why you got to get off site.
Yeah. But where go ahead.
Don't forget about the intern problem. No, I'm kidding. But
yeah.
a couple other companies, did they have that recently where an intern just pushed out some code? But anyway,
yeah. But that's part of it too. But where I wanted to go and why I like how I think that really relates to what you guys are doing at MITRE and the help there is open source. One thing we like to say is open source is amazing. It's flexible. It's the best part of it. It's kind of also the worst part of it because it can do anything, but you need to know how to bend.
It can do good or it can do evil.
You need to know how to bend it in the right way, right? Yeah. So, do I use EFS? Do I use Butterfest? Do I use some other technology? Well, you can kind of use whatever you want, but there is a best choice, in our opinion. But it's not based on which technology you choose because I just like that technology. It's what is the best choice for preventing against those perils that we laid out. Yeah. And so...
Well, and I think one of the things you guys outlined too is that you've got different stacks, right? So you have different product lines, right? And from my perspective, right, it's like I could use like, NSF and this and that and the other thing, or, XFS or, but it depends on everything else that I'm using in the system and what the function of that system is, what the best stack of, tools is. Right. And there isn't any one answer, right? I can't imagine that there would be one grandiose or universal storage device or even technology solution, right, that you could do that would be perfect for all situations.
Well, if it did, it would exist and anything else wouldn't.
Yeah, that's true. So,
yeah.
Cool.
I love that. So why don't we move to the wrap up here? I think we're at the end of our questions.
Except for the last wonderful question, which is, you've been around the industry for a long time. Some really, really cool background. Do you want to share any battle stories, war stories you'd like to share with us? Extreme technical channels, perseverance, anything? What would you share with the, let me say it this way, share with the younger folk out there, kids these days, right? As I say to you guys all the time.
Kids these days, it's those ones where you walk into a problem, you're like, this won't be too bad. You come out a changed person on the other side. Right, everyone's experienced it.
I mean, I've got all kinds of stories. I guess, the one that I would the short version of the one that I would lead with is that remember that, there's nothing new under the sun a lot of times, right? And don't forget to look backwards while you're trying to look forwards because, everything from mainframes to virtualization to containerization, everything else, right? It's like, containers is not a new thing, right? I could argue that was slices, right? Or CH-root environments, right? And, I remember when I was at the supercomputing convention in Austin in 2001, I think. And I remember getting all excited about, that was the advent of x86 virtualization, right?
Nice.
And the really old guy with the beard walked over to me from the IBM booth and he patted me on the head and he's like, yeah, that's great. We've been doing that since the 70s, young man.
Yep.
Welcome. Hey, glad you guys finally figured it out. So a lot of the battle stories that I have is realizing that the lessons from the past are just as important and that they can inform your way ahead, and to not discount, the lessons that you can get there. So I guess I don't necessarily have any unclassified, really interesting stories.
Yeah, I figured that was going to be the case. Yeah.
But I mean, there are some really neat, collaborations that I've had over the years, and it's really people's openness to be able to share their own experiences. And I'm just glad that, you guys are one of those new partners. And I look forward to everything that we try to accomplish together in the future.
Awesome. So I think what we can end on is a little bit of a plug. If there are other institutions or organizations looking to, I don't know, work with you guys, talk with you, how does that? How can they get in touch, MITRE, and get that work going?
So we've got, our normal email, so saf@mitre.org. And they can just reach out, just like you guys did. I think you guys kind of stumbled across, saf.mitre.org and, just kind of found our email. But yeah, we're always open for, partners in industry to reach out and talk with us. And even if it's not in terms of immediate action, but just we'd like to find out, here are some of the challenges we have. Do you guys have any resources that we could use? Whatever the shape of that might be. There are many ways that we could work together, and grow those partners with industry. And we are always willing to explore what that could be.
Awesome.
So don't be shy.
Okay. Well, then with that, we'll say thank you so much for joining us. This was, I don't know, I haven't said this before, but I am going to say it now. Sorry to all our other guests. This was one of my more fun conversations in a little bit, but I think it's because I met you before. So we got to have a little bit of a rapport. But again, thank you for joining us. We've really appreciated your time, your experience, and your stories.
So appreciate you sharing everything, Baron. Thank you so much.
Well, I appreciate you guys too. And, next time you guys fly down south, try to drop by Brambleton and Ashburn, and we'll crack one open and have a good meal.
Cool. Thank you very much.